Hi guys, welcome back to the Seaborn, a statistical data visualization section. We are going to talk about matrix plots in this lecture. Seaborn's matrix plot, such as heat map, allow us to plot the data as color-encoded matrices, whereas cluster map can be used to indicate clusters within the data. In this lecture, we are going to see how the heat map and cluster map looks like. Later in the machine learning section, we will learn how to formally cluster the data. Let's learn with example and start with the Jupyter notebook. First thing first again, some imports. Seaborn as SNS, import matplotlib pyplot as plt and set matplotlib inline. Then let's run this cell. So we need data to work with. Let's load two data sets again, tips, and we know how to load dataset sns dot load dataset, passing the name tips, and the second dataset flights sns dot load dataset and flights. Let's run this cell and see how the data look like. So we already have enough information on tips. Let's check the flights dataset. Flights.info, and here we have 144 entries. We have year, month, and passengers column. Let's check the head of dataset. Flights.head. So here we have the head of our dataset. So flights dataset is actually on number of passengers flew in each month on some year, like 1949 in January 112 passengers flew. April 1949 129 passengers flew. So let's start with the heat map. Heat map actually plot rectangular data as a color encoded matrix and is a primary way of showing matrix plot. In order for heat map to work properly, our data set should already be in a matrix form. The sns.heatmap function basically just color the data for us. For instance, if we take a look at our tips data frame, so tips.head, we have a column total bills, which is some sort of label. If we look at one of its values, say 16.99 at first place, the row is not actually the variable. In order to get it into a variable form, we need to have both variables on columns and rows. We can do this usually through pivot table or trying to get correlation data. And if you remember, we learned about pivot table in our previous lectures. Let's take the correlation here. Using core function on our tips dataset, we can get a matrix form of our dataset with correlation between the columns and indexes. Let's call tips.core. So here we have total bill to total bill correlation, which is 1, and it's obvious tips to tip relationship 1. So along the diagonal, we have relationship between the same variables. In the second column here, 0.67, we have a correlation between tips and total bills, and then size and total bills. We can visualize these numbers in colors. We need to simply call the heat map here. So sns dot heat map and pass in tips.core. If we run this cell, So here we have a heat map for our correlation data. Along the diagonal, the variable has correlation to itself, and off the diagonal, the variable has a correlation to another variable. We can change the color map using CMap. CMap, say we want rainbow, and rerun. Here we have rainbow. It's quite bright. Let's pass in cool warm, which is another color scheme. Here we have cool warm. We can put these numbers on the heat map as well. And for that we use anode equal to true. And if we run this cell, we have these numbers on our heat map. If you press Shift Tab, you can see range of parameters you can work with. You can go through this document to explore more on the heat map. Let's look at the flight dataset now. Remember, we need to create a pivot table first because we need to convert this data into a matrix form. Let's call our understanding of pivot table from the previous lectures. So flight dot pivot table. We have values, index, and columns. Let's copy these three arguments and paste them here. We want passengers as a value, month as our index, and the third column is year, which is our columns. So what we are expecting, our values will be the number of passengers, our index, which is along row, would be month, so each month will be a single row, and our column would be year. So let's pass into PTF, pivot table for flights, and run this cell. Let's check PTF now, and here we have years 1949 up to 60 as our columns. We have months as index, each row is a single month, and we have values, number of passengers. So now we have data into a matrix form. Now we can call heat map on our data. So let's add few cells and call heat map SNS dot heat map, and our data is PTF. So here we have what we are doing. We are calling heat map on our data PTF, which is actually in the matrix form, and we have used pivot table to convert our data into matrix form. Let's run this cell, and here we have the heat map for our data set. Let's play with the color schemes and other parameters before we discuss these plots and the data. So let's pass in CMap equal to, we can say, magma and other scheme, and run this cell here. Now we have better visualization of our data. We want to separate each block. Let's pass in another parameter, line color, and we want white here, and we say line width equal to 1, and let's run this cell. So now we have white line separating each block. Now if we look at this map, we see that the overall number of passengers increases as we move from 1949 to 1960. This makes sense because more people used airplanes with time, and more flights were available with the passage of time. We can also observe that popular months for travel are usually the summer months, July, June, and August. This is again obvious. Schools are off. People want to have some fun time during the summer month. Let's move on and talk about the cluster map now. The cluster map uses hierarchical clustering to produce a clustered version of the heat map, where similar groups are close to each other. Let's call the cluster map for the same dataset PTF. So SNS dot cluster map you can always press tab for autocomplete. Our dataset is PDF. Let's run this cell here. So this is just a warning between two versions. You can simply ignore this warning. Let's fit this. And here we have a complete cluster map on a screen. Notice that how the years and months are no longer in order, like 1949, 1950, 1954, 1953, and after 54 we have 51. And then 1955 is somewhere here. And if you look at the months, September, July, August, July, the months and years are not in order anymore because they are grouped by similarities in values. And here the values are passenger count. So if we look at the plot, July and August are similar because more people traveled in those months. That makes sense because both are summer travel months. 1959 and 1960 are similar and they put beside each other. We can play with the color schemes here as well. Like we can pass in CMap, say we want cool, warm, and rerun this cell. And here we have better visualization of our cluster map. So these months, August and July, are beside each other with darker color. 59 and 60 are beside each other, and this makes sense because they are grouped based on the similarities, based on the number of passengers. One thing notice here, we have a color bar here. The passengers are from 0 to 600. We can standardize the color scale, and that is very easy to do. Let's copy this one and paste it here. And if you press Shift Tab, you see you have a parameter standard scale. It's none by default. Let's copy this and paste it here. And our standard scale is, say we want 1. And if we rerun this cell, here we have our scale from 0 to 1. Now based on normalized scale, we get much better understanding of our data. We see that the winter months, November, February, and January, are always low passenger months, while the summer months with red color are all the time high sail or more passenger months. This was all about heat map and cluster map. I hope you have a good understanding of heat map and cluster maps and how useful they are to visualize the data. It is always important to get as much information as possible from the dataset. And these maps are very helpful to visually represent the information from our dataset. You will see that people like visual information. I hope you got a very good understanding of heat maps and cluster maps. The visual information is always helpful. You have a range of parameters to play with in these maps. See you in the next lecture, where we will talk about other important features in the Seaborn. Good luck.